Day 286 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem where we're doing daily LeetCode problems and our consistency and discipline is unmatched. Today, we have question number 300, longest increase in subsequence. The difficulty level is medium, but don't worry because we're going to keep the solution as simple and easy to understand as possible, y'all. But before we get started, don't forget to like, comment, and subscribe. And if you need any new Apple AirPods, go ahead and check out that link in the description. Now let's see what the question says. Question says, given an integer array nums, return the length of the longest strictly increasing subsequence. All right, sounds simple enough, but before we get started, let's look at the definition of subsequence. It says a subsequence is an array that can be derived from another array by deleting some or no elements without changing the order of the remaining elements. All right, y'all. So now that we know what a subsequence is, let's go ahead and start with example 1. In example 1, we have our input nums equals an array of integers 10, 9, 2, 5, 3, 7, 101, and 18. The output is 4. Explanation says the longest increasing subsequence is 237, 101. Therefore, the length is 4. So let's just go ahead and break this down one step further so we can know exactly what it is that they did, right? So we want the longest subsequence, and remember, a subsequence can be derived by deleting some or no elements, which is important, right? Because in this case, we need to delete the 5 so that we can create the longest subsequence, right, of increasing numbers, which would then that allows us to go 2, 3, 7, and 101, which is the longest increasing subsequence that we can create. As you can see with 10 and 9, that is decreasing, so we cannot include that in our output. Same when we went from 2 to 5, or not 2 to 5, but when we went from 5 to 3, when we went from 5 to 3, that's decreasing, so we can't use that as well. And same with 101, we can't use that because that's where the decreasing start. However, if we remove this 5, we can have 4 consecutive increasing numbers, which is what we want, which is the longest increasing subsequence that we can create, right? 2, 3, 7, 4. 2, 3, 7, and 101. Now, it's important to remember we're returning the count of this subsequence. We're not returning the actual element, so that's important to understand as well when we're writing our code. So now let's go ahead and look at example 2. In example 2, we have the input nums equals an array of integers 0, 1, 0, 3, 2, and 3. This time the output is still 4. As you can see, the output is 4 because we can go 0 and 1. Then we would have to delete this 0. Boom, get that out the way. Delete this 3 as well. Boom, get that 3 out the way. And then we can go 0, 1, 2, 3. And there's 2 on this side, 2, 0 and 1, that's 2. Then 2 and 3 is 3, 4. And thus the output is 4. That's the longest increasing subsequence that we can create. Now let's go ahead and look at example 3, where they might try to throw a trick question our way with all the numbers being the same. So in example 3, we have the input nums equals an array of integers 7, 7, 7, 7, 7, 7, and 7. The output is 1. The output is 1 because there's only one element that we can add to our subsequence, right? As soon as we go to the next element as all the way down, there is no increase in subsequence, right? And since nothing is all the same, nothing is increasing, then we're just going to return 1 because 7 never increases or decreases. So that is our whole substring right there. So now that we understand the question, let's get into the fun part, the actual code, y'all. And the code's not that difficult at all, so let's get started. Now, the first thing we need to do is we need to create our dynamic programming array where dp of I is going to represent the length of the longest increasing subsequence ending at index I. So in order to do that, we're just going to start with the variable. We're going to say var dp. Boom, we're going to set that equal to an array of integers. So we're going to say var dp colon int, put int inside of the colons for integers. Then we're going to set that equal to an array, and that array is going to be repeating, excuse me, y'all, repeating colon ones. So it's going to be an array of ones, integers, and all of those integers are going to be 1, and we'll say count colon nums.count. So whatever nums.count is, that's how many ones are going to be in our initial array. But it'll change as we write with the code, but that's just the our default dynamic programming array that we're going to create. Now we need to initialize a variable to track the maximum length of the longest increasing subsequence that we find. So in order to do that, we just declare a variable. We could call it max I, and we'll set that equal to 1 just to start. Now we need to iterate over each element in nums, right? So in order to do that, we're going to say for I in in 0 up to nums.count. Boom, just like that. Then we're going to open up the brackets. Now we need to check all of the previous elements before I, right? So for in this case, it'll be j up to I to find a valid subsequence. So in order to do that, we're going to say for j in 0 ... less than sign I, so 0 up to I. Then now if nums I is greater than nums j, we can extend and add that to our longest increasing subsequence, ending at j by including nums I. So in order to do that, we're just going to say if nums square bracket I is greater than nums square bracket j, what we're going to do is we're going to open up the brackets. Boom. And now we need to update our DP array to the maximum between its current value and the value of the dynamic programming j plus 1, which would include nums I in the sequence. So in order to do that, we're just going to say DP square bracket I, set that equal to max, open up the parentheses, DP square bracket I, comma, DP square bracket j, come outside that and say plus 1. Now we need to, now remember, this is going to return the maximum value of this or this. And now we need to update the global maximum, which is this this max I variable that we created up here. So in order to do that, we're going to come right here. We're going to say max I equals the max. Open up the parentheses again. We're going to say max I, comma, DP square bracket I, just like that. Now we need to return the maximum or the longest increasing subsequence, which will be stored in max I. So in order to do that, we just come right here and we say return max I, just like that. Now let's go ahead and run this. Make sure it runs like it's supposed to. Let's see. When it's accepted, y'all, so let's go ahead and submit it. Make sure it stays accepted after we submit it, because we all know how LeetCode can get. You never know. And look at that, y'all. 27 milliseconds beats 53.27% of users with Swift, y'all. We'll worry about those numbers as we continue down our LeetCode journey. Right now, we just want to be able to solve the problem that is presented to us, and I feel like this is a good solution for that, where everybody can understand what's going on, and we'll all be able to apply what we learned in this solution to further solutions down the line. So with that being said, y'all, I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. I'll see y'all then.